Selection sort basically depends on interchanging elements or swapping elements within the array itself. For every element in the array, we look for the elements on the right-hand side of this element. We try to find the one that is the minimum. Then after we found the minimum, we swap it with this element. For each number in the list at an index I, we swap it with the minimum number found in the list at subsequent indices starting from I. So you go for the first element, find which element on the right-hand side of this element until the end of the array is the minimum, you swap with that element. Then you go to the second element and look for the minimum on the right-hand side until the end of the array and also swap it with this element. So basically what you are doing, you are finding the first minimum and insert it into index 0. And then you find the second minimum and then you insert it into index 1. And so on until you put the last minimum number at the end of the array. Let me show you a demonstration on how the selection sort works on a sample of an array of integers. Imagine we have the following array. We have 5 elements of integers, 7, 2, 8, 5, and 4. So how the selection sort work on the array? It starts from the first element, which is at index 0, which is 7. And then we look for all elements on the right-hand side of 7, starting from 7. So 7, 2, 8, 5, and 4, find the minimum. So which number is the minimum? The minimum is 2. So therefore, we swap it with 7. So 2 is the minimum, will be placed at index 0. So let us see how it works. First, we will check for 2, and then we will check for 8, and then we will check for 5, and then we will check for 4. Now, which one is the minimum? The minimum is 2, so we swap it with 7, and at the end, 2 and 7 are swapped, so 2 is the first minimum, is put at index 0. Now we go for the next element, which is 7. And also we look for all elements on the right-hand side of 7, and we try to find the one that is minimum. So we have 7, we have 8, we have 5, and we have 4, and 4 is the minimum, so we swap it with 7. And after we swap 7 and 4, this is the result of the swapping. So now 2 is the first minimum, 4 is the second minimum, and they are at the right place. For next is 8. We have to look for all elements on the right-hand side of 8 and find the minimum. So we search for 8, 5, and 7, and 5 is the minimum, so we swap 5 and 8, and now 5 is the third minimum integer in the array, will be swapped with 8. So now the first minimum is inserted at index 0, second minimum at index 1, and the third minimum is inserted at index 2. Now is the time to check for 8, and also we look for all elements on the right-hand side of 8. There is only 1, and we look for the minimum. Since 7 is smaller than 8, so 7 is the minimum, so we swap it with 8, and the result will be that 7 and 8 are swapped, and now 7 is the fourth minimum put in the right place, and 8 will be at the end. So this is how the sorting algorithm works. We start from every element and look for the minimum number on the right-hand side of this element. So basically we are finding the first minimum, the second minimum, the third minimum, fourth minimum, fifth minimum, until all numbers are put in the right place. As you see, that the algorithm depends on swapping between elements inside the array. Notice that the array size is 5, so the last index will be at index 4, but for processing the elements, we process the elements from 0 until the element that is immediately before the last element, which is at index 3. So for this array, the loop will go from 0, 1, 2 up to 3, not up to 4. Remember that for for loops, if we want to use it to process an array, usually if the index variable we are using is I, we write for integer I equals 0, I less than the name of the array dot length. So this will process the whole elements in the array until the last index. However, for our selection sort, we should not compare the last element with any number on the right-hand side. Why? Because we don't have any numbers on the right-hand side of the last element. So therefore, when we reach the element that is immediately before the end, we should stop. because we don't have any numbers for the last element to compare with on the right hand side. So therefore, for processing the array index will start from 0, but it will never reach the last index. So we should go up to length minus 1. So to implement the selection sort, we will put the implementation in a static method called selection sort, and it will accept as an input parameter the array that we want to sort it. The method will have a for loop that will process the array from index 0 until the index that is immediately before the last index. So it will go up to less than but not equal to the length minus 1. In each iteration, we call a method that is responsible of finding the index of the smallest integer in the array starting from index. And index is the variable we are using in the loop. So in the beginning, if index is 0, then this method will find the index of the smallest element in the array starting from index 0. So you provide the index, the current index, and you provide the array, and this method will give you the minimum element in this array starting from this index. In the next iteration, when index becomes 1, then this method will get you the index of the smallest integer in the array starting from index 1. In the next iteration, when index is equal to 2, it will find the index of the smallest integer in the array at index 2, and so on. To understand exactly what this method is returning, get index of smallest, we will apply it on our example. Notice here, it is not getting the smallest integer. It is getting the place of the smallest integer, which is the index. So let us see what is the return value for this method when we apply it on our example. When index is equal to 0, we are referring to the element 7. So 0 is given as an input parameter and the array itself. So this method will search from index 0 until the end. Where it will find the smallest integer, it will find it here. What is its index? Its index is 1. So 1 is returned as the index of next smallest integer. So therefore, it will make a swap between these two indexed variables. And the swap is done by these 3 lines. In the next iteration, when index is equal to 1, we are talking about this index variable, which is now becomes equal to 7. And this one will be as an input parameter to the method as well as the array. So the method will look for all elements at starting from index 1 until the end. So starting from 7 goes to 8, 5, and 4. And where is the smallest integer? The smallest integer is 4. What is its index? Its index is 4. So this 4 will be the returned value and will be saved into index of next smallest. Once we return back from this method, then the interchange will be between index 1 and index 4, which is the index of the next smallest integer. In the third iteration, when index is equal to 2, so we are referring to the index variable 8, then 2 will be given as an input parameter to the method as well as the array. So it will start searching from index 2, which is 8, 5, 7. Now where is the smallest element? The smallest element is 5, so this method will return the place of this smallest integer, which is 3. The place is the index. So 3 will be returned and saved into the index of next smallest, and these 3 lines will swap the elements at index, the current index, which is 2, with the index of the smallest integer, which is 3, and the result is this array. So this is how this method is working, and this is what it is returning. It in fact returns the index, not the element itself. If you look closely on how this algorithm works, in the first iteration, this method is finding the index of the first smallest element in the array. In the second iteration, it is finding the index of the second smallest integer in the array. In the third iteration, it is finding the index of the third smallest integer in the array. So basically, it is finding the first minimum, the second minimum, third minimum until the last minimum, and put those minimum values into their right position. Let us see the implementation of this method, get index of smallest, and also show you how to use selection sort in a real program.